Hi students, this is another video on lesson 13 dealing with fractions and decimals. I want to turn your attention to page 86 where in the demonstration that you're given the instructions are that if a decimal is repeating, we should be rounding it to at least 5 places. An example shown is taking 6 divided by 9. Now I have my decimal selector on float, and you'll notice that on the display I'm seeing all of the decimals. But if I were to round this number, I want to keep it to at least 5 places in order to get the kind of precision from my calculation that will be necessary in most of the problems. I also want to direct your attention to the fractions and their equivalents that are more common, such as the fraction of 1/2, 1 divided by 5. Or excuse me, I just did 1/5. 1 divided by 5, the decimal equivalent is 0.2 or 20%. There's a table of common fractions and their equivalents on page 87, and some of those you may already have memorized from using them frequently. However, some of them are fractions that we don't deal with perhaps in our everyday life, and so we don't know the answer off the top of our head. We might need to actually do the math in order to come up with that decimal equivalent. Take a look at problem 16 on page 87. I've written it out here, and I want to demonstrate how we can do this problem by converting these fractions to decimals, but also employing the memory keys on our calculator. So let's go ahead and clear the calculator and start with a fresh tape. And so the first problem is 47 and a fraction of 11/12. So what I'm going to do is I'm going to go ahead and put 47, the whole number, into memory as a positive. Then I'm going to convert the fraction of 11 divided by 12 into its decimal equivalent, and then I'll put that into memory as a positive. Notice that the next number in the problem is also a positive number, so I'll put the whole number into memory first, convert the fraction to a decimal, and put that decimal equivalent into memory. Now notice that the third factor here is actually a negative number. So I'm going to put 35, the whole number, into memory as a negative, convert the fraction into a decimal equivalent, put that into memory as a negative, and I'll do the same thing with this next portion of the problem because it is also a negative amount. So 54 goes in a whole negative amount. I convert 1/3 to the fraction equivalent, put that into memory as a negative, and now I total my memory, and what I've been able to do on my tape is to both convert these fractions to their decimal equivalents, but also to effectively do this problem by combining the positive amounts in memory with the negative amounts in memory, and then I simply press memory total to get the answer for that problem. So that's a way that we're combining, converting fractions to decimals, and also using our memory keys. I want to point out that the problem that we just did, number 16 on page 87, where we converted our fractions to decimals and used our memory keys to help us to accumulate those positive and negative amounts, that same technique will not work for problems 21 through 25 on that same page. And the reason for that is that we can't employ that technique with the memory keys because this problem involves multiplication and division. So the way that we would do this problem is we would need to actually convert our fractions to decimals prior to inputting the problem to the calculator. So 12.5 we would convert to 12.5, 54 1/4 would convert to 54.25, 55 5/8 to 55.625, then we would do our input. So we would take the decimal equivalents, do our multiplication, There's our first answer to this portion in the parentheses. Then that would be divided by the final factor, and that's how we would do that problem using the calculator. Hi students, I want to go over lesson 14 on percents with you in this video. This lesson focuses on percents, and by percent we really mean simply hundredths or parts in 100. For instance, let's take a look at this problem. 25 parts of 100 is expressed in this fraction, with 25 being the numerator and 100 being the denominator or base. We convert that to a decimal equivalent by doing the division, dividing 25 by 100. 0.25 is our decimal equivalent. We then can convert that decimal to a percentage by simply timesing it by 100. Or, said another way, if we move that decimal point 2 places to the right, and therefore the decimal place is here now, and we simply put a percent sign, we've converted it. But what we're really doing is taking that decimal times 100. Now we can work the other way as well. If we're working from a percentage and we want to work back to the fraction, we take that percentage amount, divide it by 100, get the decimal equivalent, and then we know that the numerator is 25 and the denominator is 100. So whether you're given a fraction and you want to work your way from the fraction to the decimal to the percent, or you're given the percentage and you want to work your way back to the fraction, that can be done. So the problems that you're going to be doing in this section involve review of these concepts. If you believe that some additional review of these concepts would be beneficial for you, I would encourage you to take a look at the Basic Math Review Book, posted on our Canvas site or available at the BTC Library and also in the bookstore. It'll give you a little bit more practice with fractions, their decimal equivalents, and percents. Hi students, in this video we're going to review some of the concepts in lesson 15 about finding percentage, rate, and base. I'd like you to take a look at the handout provided on the Canvas site. And in this handout you can see here that we show the relationship of portion, base, and rate or percentage, with portion being the is part of a lot of these story problems that we're going to be going through, and base being the of, and then rate being the percentage. So if we have two of these three factors, we can always solve for the third. Let's take a look at these problems on the back of the handout and apply this concept and use our calculators to do the problems. So again, the portion or part is generally going to be the is part of the story problem, and then the base is going to be the portion of, and percent is our rate. So let's take a look at what's missing and what we're solving for in this particular problem. We're going to set our decimal selector at 2. So the problem is 6 is 15% of what number? So it's the of, or the base amount, that's missing. Therefore, the two factors that we have are the part or the portion and the rate. So 6 becomes the part. We divide it by the rate of 15%, which we convert to a decimal form so that we can actually do the math. Now we simply take 6 divided by 0.15, and we find out the answer is 40. In other words, 15% of 40 is 6. Now we can test that by simply doing the reverse math. Let's take a look at the second one. What is 4% of 172.5? So we have the base amount and we have the rate. In this case, what's missing is the portion or the part. The part is missing. So when the part is missing, the formula to find that is to take your base times your percent or rate. So our base in this case is 172.5, and we're going to take that times 4%, which we've got to convert to a decimal to work with it. So 172.5 times 0.04, and we get 6.9. So what is 4% of 172.5? 6.9 is 4% of that base. Let's take a look at this third one. What percentage of 300 is 50? So in this case, it's the rate or percentage that's missing. So the formula to find the percentage is to take the part or portion and divide it by the base. So of is the base, so that's our denominator, and 50 is the part, the top or the numerator, so this becomes a division problem. 50 divided by 300 is 0.17. Okay, that's the decimal form. Remember, we're moving the decimal over to convert it to a percent, so the answer is 17%. So I think this handout will be very helpful as you go through these problems in Lesson 15. This is Take 2, Lesson 16. Students, we're going to focus on Lesson 16 in this video, the amounts and percents of increase or decrease. One thing I want to point out before we get too far is the fact that if you look at page 102 and 103, where we're looking at comparative financial statements, I want you to notice that the first column that is being shown is actually the most recent year, or therefore the new information. And the column to the right of it would be the prior year or the old information. Now this becomes quite important when we're taking a look at how amounts have increased or decreased from one period to the next. Take a look at your handout provided on the Canvas site, and we're going to do some demonstration problems. Let's first turn to page 100, and we're going to do the demonstration problem there, where we're looking at the new information, the sales this year, to be $661,200, whereas last year's sales totaled only $580,000. So first we want to calculate what's the amount of the change and then what is the percent of the change. So we do that by taking the new or most recent information, subtracting the old from it. That allows us to get the amount of the change, which in fact would be an increase. Then we take that increase and we divide it by the prior year or the old information. This gives us the decimal equivalent of the rate, which we then convert to a percent. So let's do that together. So the new amount less the old amount. Whoops, I made a mistake. I'm going to start over. The new amount, $661,200. The old amount, $580,000. That allows us to compute the difference, which is an increase of $81,200. Now we take that and we divide it by the old base amount of $580,000, and we find out that 0.14, the decimal equivalent, is the rate of the change, and that then gets converted to a percentage of 14%. Let's take a look at the demonstration problem on page 101. In this case, we have a pair of slacks that once cost $36. They've been marked down to $26.99. We want to know what is the amount and the percentage of this decrease. So we would take the new price, $26.99. We would subtract the old price from it. And notice that what that produces is a negative amount. You'll see it in red there, 9.01. That negative amount reflects a decrease, so the price decreased by that amount. Now we're going to take that amount and divide it by the old price of $36 to determine what the rate of that decrease would be. The rate would be 0.25, or if my decimal was floating, 0.2503, and that converts to a percentage decrease of 25.03%. So remember to always divide by the old to get the percent of increase or decrease in this particular lesson.